So what I've done is I've scooted down to page 18 of your booklets because this is another experiment to show that Q equals CV. So to do this experiment, what you need to do is you set up a circuit with a capacitor, with a 6-volt battery in the circuit, and a variable resistor. And to do this experiment, what you need to do is you have to be very careful to keep the current steady. So you have to keep changing your variable resistor because obviously as the capacitor charges, the current will change because it will be taking some voltage out of the circuit because it will be building up on the capacitor. So, so to do this experiment, what you do is every 10 seconds you measure the charge. Sorry, every 10 seconds you measure the voltage across the capacitor. And if you're keeping the current steady at 0.5 milliamps, then you can work out the charge by using the equation charge equals current times time. So this column here is just working out a sum. So the first one is 0 times 0.5 milliamps, which is 0. The next one is 0.5 milliamps times by 10, which is 5 millicoulombs. The next one is 0.5 milliamps times by 20, which is 10 millicoulombs. So that's just basically doing maths. This entire column here is just Q equals IT each time. You're not actually measuring that. But what you are measuring is the voltage across the capacitor after each 10 seconds. So you can see the voltage across the capacitor increases every 10 seconds, sort of increases by the same amount every 10 seconds, and as you double it, it also doubles. So to do this, what you would do is you plot the charge, which you've worked out using Q equals IT, and the voltage, and again you get a straight line through the origin where the gradient is the capacitance of the capacitor. So the gradient of this, because the capacitor is 4,700 microfarads, then the gradient would be 4,700 microfarads. So just a conclusion, another way to show that Q equals CV.